Free response question here. This is AB Form B from 2009, number 4. Let's get started. This is a no calculator problem. Let R be the region bounded by the graphs of the square root of x and y equals x over 2. And we want to find the area of R. Okay, so to find area, this is from section 7.1 if you were looking for some reviewing. We want to go from 0 to 4, and then to find the area we just do top minus bottom. That's the integral. And then we got to find the antiderivatives. This is x to the 1/2. That to find the antiderivative, we up the exponent by 1 and then divide by the new exponent. Here, up the exponent by 1 and divide by the new exponent. You just really cannot afford to mess that kind of thing up. That's just easy calculus. So do it carefully. Okay, now we have to do some math. This is not a calculator problem, so you need to be able to do 4 to the 3/2 power by your big kid self. So 4 raised to the 3/2 power. The 2 on the bottom means square root. The square root of 4 is 2, cubed is 8. So that's 2/3 times 8. Minus, when I plug the 4 in here, that's 16 over 4. And then minus, when I plug 0 in here, I do get 0 for both of those. You can leave the answer like this. That is totally 100% allowed. If you simplify, then this is going to be 16/3 and minus 4, which is 12/3. So that would be 4/3 if you choose to simplify that. But why would you, really? I mean, once you get all numbers, you're good. All right, part B. The region R is the base of a solid. Okay, for this solid, the cross-sections perpendicular to the x-axis, that's slicing this way, are squares. Find the volume. Okay, so remember how this game works. Since we're slicing perpendicular to the x-axis, then that's like one side of the square. The square would be like coming coming up out of the page. I can say words sometimes. And the side of the square would be this top one minus the bottom one. So the side of each square would be the square root of x minus x over 2. And then the area of each square would be that squared. Alright? We're slicing perpendicular to the x-axis, so we are going from 0 to 4. Alright, now they want us to actually evaluate this, so we got to do some algebra here. I think I'm going to do a little bit of scratch work. Maybe I'll do it up here, because I got some room. So the square root of x, I think I'm going to write that as x to the 1/2, and then I'm going to write this as 1/2 x. And I'm squaring this, which means I have to FOIL it out. This is about as intense the algebra that they usually expect us to do in these problems. So let's see how we can do. X to the 1/2 times x to the 1/2. We add the exponents, that's x to the 1. Minus, now I'm going to do the outside and inside of the FOIL. Now I'm squaring this, so those are both the same. So this is minus 1/2 x to the 3/2. I'm adding the x to the 1 and the 1/2, add the exponents there, minus 1/2 x to the 3/2. But there's 2 of those, so minus 1/2 minus 1/2, that gives me minus a whole x to the 3/2. Plus, that was my first outside inside, and then last is going to be plus 1/4 x squared. All right, so that's my antiderivative. Going from 0 to 4. When I put the 0 in, that's just going to be 0, so that's good news. So I get 4 minus 4 to the 3 halves. The square root of 4 is 2, cubed is 8, plus 1/4 times 4 squared. Oh, did I drop something? Hold on a second. Oh, hold on. I'm doing something bad here. I have not found the antiderivative of this yet. So I'm not at this stage. That would be a very big mistake if you didn't catch that. So I'm still doing the integral here, right? So now I'm going to find the antiderivative. Right, we only did algebra to the inside of this. We didn't actually do the calculus yet. So that's x squared over 2 minus, bump the exponent up by 1 and divide by the new exponent, plus bump the exponent up by 1 and divide by that new exponent. So 0 to 4. And that's going to give me 4 squared over 2 minus 4 to the 5 halves. This is, the square root of 4 is 2 to the 5th power is 32 times 2, and then plus 4 cubed is 64 over 12. I mean, that's a mess. You want to simplify that? I wouldn't if I were you. But if you do, you're going to get 8 over 15. All right. For C, write but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 2. I'm going to just draw that in here. Right, if you need to review this rotating around other axes, you can find that in section 7.2. I need a little bit more room here, so I'm going to borrow an extra piece of paper. So here, we're rotating around this horizontal line, which is parallel to the x-axis. So this is still a dx problem. But we're rotating around this line, so if you kind of picture the solid, which I think is really helpful to do, when I rotate that around here, it's going to look like this. So this is like an outside radius minus inside radius problem, and it's got shifted around this line. So how do we set up that integral? We do pi from 0 to 4. And then the outside radius is defined by our line, x over 2, right, because it's the outside of our solid here. And then I shifted by 2, so I'm going to do the minus 2 inside there, squared. So that's pi times the outside radius squared. You cannot forget that shift there. And then the inside radius is my square root of x, and then the shift squared. Those are a little tricky, but if you remember the rules of how to set that up, you will be okay. I think that you've got to do some drawing there to make it happen.